Good evening, everyone. So today, let us discuss about soil compaction a bit more. Okay, so we'll go into some more details on soil compaction. So, um, what was the purpose of soil compaction? The main purpose of soil compaction is to increase the density of soil and uh, decrease the air voids, obviously. Decrease the air voids in the sample. So these are the two basic purpose of soil compaction, two basic effects we get from soil compaction: increase the density of soil and decrease in the air voids. Okay, now the compaction is measured in terms of dry unit weight. Okay, it is measured in terms of dry unit weight. Dry unit weight, this one. Okay, and now the various factors that affect the compaction are what? The various factors that affect the compaction are water content, then number two, compactive effort, number three, type of soil, and number four, method of compaction. What method you use for compaction, that also affects the compaction. Okay, so the factors affecting compaction are these. Okay, are these. Okay, so and I would like to give you a revision also. We have already discussed this curve. Okay, where like dry unit weight it increases and then decreases, and the point where it is highest, the moisture content is called as the optimum moisture content, and that is the maximum dry density. Okay, and then zero air void line we have already discussed. Like if you increase the compactive effort, it will go like this, isn't it? If you keep on increasing, then there is a zero air void line like this. Okay, it will not touch these curves. Okay, not touch these curves. And this zero air void line is when 100% saturation is there, when S equal to 1. Okay, or you can say this is 100%. Okay, then we get the zero air void line. Okay, so I also recommend you to please do a bit of a revision of these things that we have studied in the previous videos. Now in this diagram, let me erase It's okay, fine. This part is called as the dry side of optimum, and this part is called as the wet side of optimum. Okay, and when you give a compactive effort, now let me take a new screen, then I will be able to explain it in a much better way. So suppose this one is the curve. So when you're giving a higher compactive effort, okay, then the increase in dry unit weight is more on the dry side. This is the dry side, this is the wet side. So suppose this part I am telling, so this part might increase a very high, like it can reach like this part. Okay, and this part will also suppose reach here, and this part suppose it reaches here, but this part on the wet side it will not reach up to that level, it may reach up to like here, and this part might reach up to here, this part might reach up to here. So when you join it at a higher compactive effort, you are ultimately getting something like this. That means the increase in this dry side is of the dry unit weight is much more than on the wet side. Okay, so um, you should also try to write it down. That will be much better. So I'll just write it. You copy it in your notebooks. Okay, so we can write one line that dry unit weight on the wet side of optimum is not significant compared to the compared to the increase of dry unit weight on the dry side of optimum. So please write it down. Okay, and we have also discussed this one. Okay, like suppose this one is the curve on increasing the compactive effort, what we get like this, again like this, and like this. And if we join the points of maximum dry unit weight here, 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 okay, this is called as the line of optimum. And the zero air void line is parallel to the line of optimum. Okay, so this is the suppose zero air void line, and this is the line of optimum. So these are parallel. Okay, uh, and no matter how much compaction we give these curves, okay, no matter how much compaction we give these curves, and these curves cannot reach this zero air void line, can never reach this zero air void line, because we cannot achieve s equal to 1 in real life. Okay, some amount of air will always be there, and if there is some air, then s will always be less than 1. Okay, so no matter whatever compaction we give, we cannot expel all the air out. Okay, so so there will be some air left, so s will be less than 1, so we can never reach s equal to 1. Okay, one more time I am repeating, s equal to 1 is achieved when all the air is expelled. S equal to 1 is achieved when all the air is expelled, which we cannot do in real. So we cannot expel all the air in real, so we cannot achieve s equal to 1 in real. So s will always be less than 1. Okay, now let us discuss about the effect of type of soil on compaction. So for type of soil, the effect of type of soil on compaction is that if there are fines in the soil sample, then the dry unit weight will be more. Weight will be more. And if if the soil sample has uniform sand or gravel, okay, if there is uniform sand or gravel, then dry unit weight will be less. Why we are mentioning dry unit weight? Because we measure compaction with dry unit weight. If dry unit weight is more, means compaction is more. If dry unit weight is less, it means compaction is less. And that's why we measure the compaction by dry unit weight. So if there are fines in the soil sample, then the compaction will be more. And if there is uniform sand or gravel in the soil sample, then dry unit weight, or we can say compaction, will be less. What do you mean by uniform? Uniform means when all the particles are of the same size. In that case, the compaction will be less, or you can say dry unit weight will be less. Okay, so I hope you are clear with this point. Now let us discuss about another concept, which is called as bulking of sand. Bulking of sand. Now one thing you should remember, compaction is measured by dry unit weight, isn't it? Compaction is measured by dry unit weight, and dry unit weight is generally what? Weight per unit volume. Okay, weight per unit volume. So one thing you please understand, that when volume is increasing, then what will happen? This dry unit weight will decrease, because volume is in the denominator, isn't it? This is equal to weight by volume. We know dry unit weight is equal to weight by volume, dry weight by volume. Okay, so volume, when it is increasing, then dry unit weight will decrease, and ultimately it means compaction will decrease. So If volume increases, then compaction decreases, dry unit weight decreases. Now, what happens in bulking of sand? Bulking of sand happens generally when the moisture content is around 4 to 5%. Okay, so what happens is that when dry sand comes in contact with moisture, so I'll write it down. You also please copy what I have written. When dry sand comes in contact with water or we can say moisture, then a thin film is formed around the particles. Okay, so a thin film is formed around the particles. Okay, which causes them to get apart from each other. Okay, write it down, which causes them to get apart from each other, which results in the increase in volume. Resulting in the increase in volume. So what I've said is, suppose I am taking two sand particles. Suppose two sand particles or three sand particles we are taking, like this one. Okay. So when water is coming in contact with the surface, okay, when the dry sand comes in contact with the moisture, that means this water is also coming in contact with the sand particles, then the water forms a thin film along the surface of the particles. The water is making a thin film along the surface of the particles, and which causes them to move apart. So now they move apart because these films, they start giving repelling each other. Okay, because there is films that are formed, okay, along the surface of the particles, so it starts repelling them. Okay, and ultimately they move away from each other like this. Initially they were closer to each other, then they start moving away. So ultimately what happens? Volume increases. So that is called as bulking, and this happens in sand. So that's why we call it as bulking of sand, and it happens when the moisture is generally 4 to 5%. This is a common question that is asked in like MCQs. They will give you the question like, when does bulking of sand occur? They will give you options like 10%, 2%, 5%, 8%. You have to select 5%. Okay, so uh, in this way bulking of sand happens. So when bulking of sand happens, volume increases, means this dry unit weight decreases. So if I now try to draw it for the sand, so suppose this one is the point where the moisture content is 4%. So at first what happened, the volume increases when it is 4%, so the dry unit weight it decreases. So this is the dry unit weight, it decreases because volume is increasing. And then what happens is, when the amount of water is increasing, okay, when this amount of water is increasing, then these capillaries, they gets broken. Okay, these are what? These are layers that are formed along the surface of the sand particles. So these layers, which are making a thin film along the surface of the sand particles, these layers gets broken when the water content increases, and then these particles again come closer to each other because the and these films gets broken. So again it comes closer to each other. Then what happens? The volume decreases because the particles are coming closer. So the volume decreases means dry unit weight will start increasing like this. So that is the concept of bulking of sand. Okay, so I hope you were clear with it. And generally, uh, what the main thing that you need to remember from him here is the percentage, 4% to 5%. Okay, this is the very common question that comes from this concept. Okay, so I hope you are clear. Now there was one more factor which affected compaction. It is the method of compaction. Method of compaction means the generally the equipments that you use, okay, how you compact it. Okay, one was the compactive effort, means how much energy you are giving in compaction, how much force you are giving in compaction. That was called as the compactive effort. But this one is called as the method of compaction, means how you are compacting it. So there are various like equipments there. One is called as the sheep foot roller. Sheep foot roller is used when the soils are clay or the soils have plasticity. Okay, clay soils or soils having plasticity. Then there are another called as vibratory rollers. Another equipments, vibratory rollers. They are generally used for cohesionless soils. Cohesionless soils means which does not have cohesion, which does not generally have clayey or silty particles there. Okay, because clayey soils or silty soils, they have cohesion. Okay, so vibratory rollers are for soils which does not have this clayey and silty soils, so that they become cohesionless. Okay, so that is the thing you need to know. Like these are the rollers that you need to use for compaction for these type of soils. Now let us discuss something about the orientation of particles in the soil sample. Okay, on the dry side and on the wet side of the optimum moisture content. So suppose like this one, uh, suppose this one is the curve. Okay, optimum moisture content. This one is the dry side. This one is the wet side. So on the dry side, suppose this is the soil sample. On the dry side, the particles are not generally arranged in a dispersed manner. Okay, but on the wet side, the particles are more like oriented in a dispersed manner. Okay, so this thing you have to write it down, that uh, for a certain compactive effort. Okay, that means suppose you are giving some higher compaction, then this curve will go above, right? Okay, then you see on the dry side also, if you are giving a higher compactive effort, then also like the dispersed will not be so much, so good. Okay, but here the dispersion will be very nicely done on the wet side. Okay, so basically uh, you have to write that for a given compactive effort, suppose for this particular compactive effort, this is another for higher compactive effort, suppose let us concentrate on this one. Okay, this one. So for a given compactive effort, the wet side of optimum gives dispersed structure. So you can write it down. The wet side of optimum gives a dispersed structure. Okay, and now uh, if I talk about how the permeability gets affected, permeability of the soil sample gets affected. Suppose this one was the thing that we are talking about: dry side, wet side, optimum moisture content, maximum dry unit weight. So as we have said, for the permeability it decreases with increase in the moisture content. That means as you go from here, increase in the moisture content, like here, the permeability starts decreasing, and it's the lowest. Okay, slightly above the optimum moisture content. That means somewhere here, the permeability is the lowest. That means K permeability is the lowest. Okay, K starts decreasing. K starts decreasing, and K is the lowest here somewhere. Then uh, beyond here, the K increases. Okay, beyond here, K increases. Okay, so it means at this part, as we go like here and here, as we increase the optimum moisture content, this permeability increases. K K decreases. Sorry, K decreases. K starts decreasing and at somewhere a little beyond OMC, K is the lowest, and then beyond there, K again starts increasing. So this is the pattern of the permeability that you need to know. Permeability starts decreasing on the dry unit weight, and just slightly beyond the optimum moisture content, permeability is the lowest, and then it increases. Okay, I hope I am clear with it. Moreover, if we talk about swelling and shrinking of the soil, if we talk about swelling and shrinking of the soil, then what we can say is, as we all know, that on the dry side of optimum, the particles are in a dispersed way, in not so dispersed way, but on the wet side, the particles are dispersed. Okay, so somewhere some puja is happening. So I hope it is not like I hope my voice is clear still. Okay, so uh, now uh, if I tell about swelling, swelling is more on the dry side. That means on the dry side, if there is water present, okay, the chances of swelling is more. Okay, and on the wet side, shrinkage is more. That means chances of shrinking is more on the wet side. Okay, and on the wet side, shrinkage is more and it is more compressible also. More compressible also. And on the dry side, it is less compressible. You can just imagine on the why it is less compressible on dry side and more compressible on the wet side, because on the dry side, if you have something which is the where the particles are like this, and if you give a force, how much will you able to compress it? And suppose on the other hand you have something arranged in this manner, okay, something arranged in an orderly manner like this, arranged in a very orderly manner, and if you give a compaction, if you give a compaction, then obviously this will get compressed more, right, than compared to this. So that's why I tell you that on the wet side the soil becomes more compressible, okay, shrinkage is also more, okay, and swelling will be more on the dry side. Okay, I hope I am clear with it. So I think today it will be enough. Okay, let's meet in the next video. Thank you very much.